Hello YouTube. We're told by scientists that the universe is expanding. Whether this is true or not, and we'll talk about it later, but the latest research claims it's about to stop expansion, and then the universe starts to shrink. And then what will happen to human beings? What will become of us? There's a study that's published in the prestigious journal Proceedings of the National Academy of Sciences, and it's dedicated to the dark energy, the one that from the point of view of modern science makes the universe expand faster and faster. The reservation about the point of view is extremely important. Dark energy is the most clumsy and incomprehensible construction of astrophysics, and scientists are eager to abandon it. Until recently, researchers did not agree that the universe is accelerating. Then the accelerated expansion of the universe was proved by observations, and the question came up about the force that gives the universe acceleration. So they hastily quickly invented a certain dark energy. It is not visible, but it is there. They thought they invented it for a while, but 30 years have already passed, and it seems that scientists invented it forever. The authors of the new study applied a revolutionary approach. Dark energy, they say, still exists, but it is not a force of nature. This is entity that they call the quintessence. And this entity is about to disintegrate. And if so, the universe will begin to shrink. Where is the proof, you may ask? But I'll surprise you. Physics works a little differently. First, scientists make a mathematical model. You can assume anything in it. For example, that the Earth is flat. If the model explains the world well, you need to look at what it predicts. Finally, when the predictions come true, physicists will say that the model may be correct. As a rule, if the model is beautiful, so to say, convincing and elegant, it turns out to be correct. So the authors of this study suggested that the dark energy is some kind of a haze, a fog, a ghost, and the dawn is coming soon, and that ghost will disappear. They ran the numbers and everything worked out. The model is beautiful and convincing. This does not mean that it's true, but the probability is quite serious. Well, what about the predictions? It turned out that despite the fact that the universe has been expanding for almost 14 billion years, it does not have long left. The universe will stop surprisingly quickly and begin to shrink. How fast? Here, don't make any change in plans. I have to disappoint you. After all, it's not going to be tomorrow. After about 100 million years from now, which is very small on a cosmic and even terrestrial scale. Look, the era and the age of dinosaurs ended 65 million years ago. So for science, if it's not like yesterday, then almost the day before yesterday. So what happens when the universe first stops and then turns around? The easiest way would be to say that we will not feel anything on Earth. The universe is huge, the Earth is a grain of sand. But this is hardly the case. Imagine that you are riding on a train that goes surprisingly smoothly. You do not feel its course and behave as if you are on a solid ground. And suddenly it stops. Boxes are flying at you from above. You yourself bounce into a corner. There are screams and ouches and things like that. People complaining from everywhere. About the same thing will happen to the universe when it stops expanding. What will happen then? When the universe shrinks and becomes tiny, it will warm up. Atoms and molecules will be crushed to dust. The universe will flare up and the Big Bang will happen again. At least that's what we think. But the good question is it true that the universe is expanding? This knowledge is based on the fact that distant galaxies look increasingly red. Their color changes because they seem to be moving away from us, and the Doppler effect is triggered. For example, the whistle of a departing train seems to be becoming less and less, as the distance grows. For light, the low is color red. But what if the Doppler effect has nothing to do with it, and the photons just get tired on the way to us? They lose energy and appear to be redder, of a more red hue. Well, there are other possibilities. It is possible that the expansion of the universe is just an illusion. There is no dark energy, and the new construction of astrophysicists is just an elegant mind game. Did you know that we only see a very small part of the universe? The rest of it is inaccessible to us Earthlings. And all that we see is called the observable universe. This is the part of the cosmos or space that can theoretically be observed from Earth. Theoretically, not in practice. Because in practice, space objects located outside the solar system can be observed only by analyzing the electromagnetic radiation emitted by them. Therefore, those places of the outer space where it is not radiated or where it is too weak for perception, no one can see. Even if you really want to. If we take it as an axiom that the space has an isotropic structure, then the observable universe will have the shape of a sphere, the center of which will be our planet. The radius of this sphere is approximately 46.5 billion light years. The age of the universe itself is estimated at 13.75 billion years. Yes, the radius of the sphere containing the entire observable universe is greater than the age of the universe itself. How so, you ask? How was the light able to cover a distance almost 4 times greater than it could during this time? Could it have moved faster before? Science has no answer to these questions. In fact, this is because our universe is constantly expanding. And according to some scientists, or most, therefore on Earth it is now possible to see the light of a galaxy that is currently 46.5 billion light years away from us. When this light was emitted, this galaxy was much closer to us, and now it is much further away because of the expansion of the universe. That's why it took this light only 13.75 billion years to reach us, although now this galaxy is much further away than 13.75 billion light years. Consequently, the observable universe has a radius usually defined as the distance at which the most distant observable objects are now relative to us. And we see these objects as they were when they were much closer to us. So what can we see in the future? Over time, the observable universe is getting bigger and bigger because the light coming from somewhere in its distant depths reaches our eyes again and again. However, there is a limit to the development of such a phenomenon because the observable universe has a size that it can never exceed. After all, photons that are emitted by objects moving away from us faster than the speed of light due to the expansion of the universe will never reach Earth. The expansion of the universe, in fact, is one of the most interesting mysteries of cosmology. After all the results of observations show that space is not just constantly expanding, as for example an inflated balloon does, and it expands with acceleration. One of the consequences of this phenomenon can be recognized as the law of universal scattering of galaxies, or Hubble's law. The galaxies are moving away from Earth at speeds proportional to their distance. In other words, the further they are, the faster they are moving away from Earth. The velocity of the galaxies has been determined by their red shift, a shift of the light they emit towards the red end of the visible spectrum. The law allows you to calculate distances to distant space objects using the features of the electromagnetic wave spectra emitted by them. All galaxies except those close enough to be affected by the gravity of the Milky Way, such as the Andromeda Galaxy, seem to be moving away from us because the spectrum of their radiation is shifted to the red side. However, in fact, these galaxies do not fly through space at all. They seem to hang in it more or less motionless. The very space in which they are located moves. Put two dots on the inflated balloon mentioned above with a felt tip pen and keep inflating it. See? These points begin to move away from each other simply because the area of the balloon increases. And now an interesting question arises. Does it turn out that the space around us is expanding? Why then is the distance from Moscow to Vladivostok by rail is still 9,288 kilometers, as it was 20 years ago, and the driving distance from Beijing to Shanghai is still 1,213 kilometers? The point here in general is this: gravitationally bound objects can maintain a constant distance between themselves due to the action of the aforementioned gravity, because they are constantly attracted to each other. In fact, two connected objects are not hanging motionless, as it may seem, but in fact they are constantly flying through continuously emerging volumes of space towards each other. Despite serious advances in technology and various smart sciences, the universe still has an incalculable number of mysteries in store for us, and some of them are absolutely incomprehensible to human understanding. Yes, we have already learned a lot about our place in space and about its colossal scale over the past few decades. But the real truth is that we have just begun to know this world, and we're just beginning to realize that the more we learn, the less we know. We have just stepped onto the threshold of a huge library, and we were able to see only the bindings of the books closest to us, of which there are incalculable number on the shelves. What is written in each of them? Perhaps only the librarian, who is still invisible to us, knows about this. Let's look at some enigmas of the universe. First of all, are there other universes? In science fiction, the subject of the existence of other universes is very often used. And having read such books, I suppose, in recent years, scientists have seriously begun to consider the idea that there may be other universes too, and that we live only in one of the countless universes that exists in the cosmos or space. And if so, just imagine your almost exact copy lives in each of these worlds. They can live exactly the same life. Only your name, for example, is Jonathan here and not James, as it would be somewhere else. However, this idea is only a hypothesis, which is extremely difficult to test with the help of modern technologies. So let's look at the black holes. Can black holes be portals to other universes? Black holes are one of the biggest mysteries of the universe. These space predators are able to concentrate a huge amount of matter in relatively small volumes of space. Even the light cannot leave these gloomy holes. No other space object in the universe can do this. There are periodic speculations in the media that black holes can be portals to other worlds, and it should be noted some mathematical calculations allow for such things. However, so far, no one has managed to make such a journey. because people are simply afraid to dive into the unknown. And the nearest black hole is not very close. It's about 1,000 light years from Earth. Now, another great mystery that keeps scientists awake is dark energy, about which we talked before. I gave you opinion of the American scientist. Now you're listening to the opinions of that young Russian scientist Sergei, who had worked on the International Space projects and is a graduate of the prestigious military space Mazhaysky Academy. And he's somebody I like to listen to. I may not agree, but he knows what he's talking about. He's done his homework. So, dark energy. It is believed that it is this cosmic force that opposes gravity. No one has ever registered dark energy. No one has ever seen it. Its existence is not provided for by modern physical models of our world. It was invented only in order to somehow explain the accelerating expansion of the universe, which we talked about above. Before, it is believed that the visible universe, consisting of stars, planets, black holes, and much more, is only 4.9% of the outer space. 26.8% is occupied by dark matter, which we'll talk about separately again, and the remaining 68.3 is dark energy. Well, gravity. This force acts over vast distances. It permeates galaxies and even groups of galaxies, and even their huge clusters. It would seem, here it is, the true power. However, in fact, gravity is much weaker than other fundamental forces, such as electromagnetic or nuclear interaction. However, the peculiarity of gravity is that, as mentioned before, it acts in the universe on a large scale, and it also has a feature to it. This is the only fundamental force that has no counterpart with the opposite sign. It can only attract. Weird, right? Is the universe really infinite? And if it is infinite, then how is this possible? How can it be that space does not end anywhere? Or does it still have a certain limit? And if there is one, what is there beyond that limit? Of all the scientific questions that you may suddenly think about, the one concerning the infinity of the universe is undoubtedly one of the most difficult. And at the moment, it is impossible to answer it unequivocally. Scientists suggest that both possibilities are real, and each approach has its supporters and opponents. Establishing the truth about whether the universe has any boundaries ultimately depends on figuring out its shape and size, and what part of the cosmos or outer space we actually observe in fact. So what form, what shape does the universe have? Only the establishment of the true shape of the universe can reveal to us the truth about what size it really has. Cosmologists suggest that the universe can probably have one of three possible shapes that depend on the curvature of space. According to some researchers, the universe may be flat, that is, without curvature, and at the same time infinite. And it can also be open and have the shape of a saddle with negative curvature, and again, endless or infinite. And the third option, so to say, the most accessible for understanding by our limited three-dimensional brain. The universe can be closed. It may be like a kind of four-dimensional sphere and be quite the ultimate within itself. What do you think about all this? Do you agree that the more we investigate, the less we know? Our universe is just filled with riddles, enigmas, and mysteries. And in order to fully understand it, we must overcome the invisible boundaries that bind our minds. So what is the shape of the universe really, right? The Nobel Prize winning cosmologist John Mather from the Goddard Space Flight Center in NASA recently expressed his opinion on this. He claims that the observations of cosmic microwave background radiation left over from the Big Bang confirm the idea of a flat universe, and that it does not have any curvature, at least within the observed space. That's what NASA says, so to say. The universe is flat, like an infinite sheet of paper, Mather said. You can keep moving indefinitely in any direction, and the universe will be the same everywhere as it is here. That is more or less homogeneous. Current calculations say that the observable universe stretches 46.5 billion light years in all directions, and its diameter is 93 billion light years across. Why did this happen? After all, the age of the universe is 13.8 billion years. So there is like a nuance here. Fine point, light flying from the furthest edge of the observable universe took 13.8 billion years to reach our eyes. However, since the Big Bang, the universe has continued to expand at a rate that seems to be increasing all the time. And even for the most remote borders, it already significantly exceeds the speed of light. That is why the edge of the observable universe has moved very far away from us, and it is already at the distance of 46.5 billion light years. So as you can see, the Americans and the Russians agree on that. According to various estimates, this vast space includes from 200 billion to 2 trillion galaxies. Think about this. And in each of these galaxies, on an average, there are at least 100 billion stars. These gigantic numbers are simply impossible to comprehend. But how did the scientists calculate all this? To do this, they use various tools and methods called the cosmic distance ladder. They start with distances that can be measured directly. For example, when reflecting radio waves from nearby bodies in the solar system. To do this, the time after which these radio waves return back to Earth is measured. Since the speed of propagation of radio waves is known, the distance they have traveled is calculated by the time of their delay. For distances that are more difficult to measure, such as galaxies at the edge of the universe, astronomers use conclusions based on calculations and observational data. For example, they use the parallax measurement method. It is based on measuring the displacement of a star relative to objects on its background, as well as information about the main sequence, which contains all our knowledge about the evolution of stars, and accordingly about their luminosity class. Knowing how the brightness of a star is related to the distance to it is of paramount importance when determining the location of very distant objects. The same thing happens with redshift analysis, which involves measuring changes in the wavelengths of light coming from distant galaxies. But what about the unobservable universe? If you noticed, all the above numbers and facts relate to the observable part of the universe, or that spherical part of the cosmos that can somehow be seen from Earth, or be detected using space telescopes and probes. But what about the parts of the universe that we cannot see? After all, some of them may be too far away from us for the light emitted after the Big Bang to reach the Earth. A study conducted by a group of British scientists has shown that the actual size of the universe can be at least 250 times larger than what we observe. The researchers calculated that the closed and finite universe will contain approximately 250 to 400 volumes of the part of it that we observe. Another hypothesis voiced by scientists as Nobel Prize winner Roger Penrose is that the Big Bang was just one of the episodes of cosmic evolution that is happening to our universe. And in fact, there could have been several big explosions, big bangs, followed by the so-called big compressions. That is, there are periods when the universe stops expanding and collapses, only to explode again later. Another question, does the universe have an edge? And yet, is the universe finite? Or is it an ever-expanding bubble that has an edge? Is there a place in space where you can walk up, look down and say, yeah, here it is, the end of the universe, there is nothing further? Most likely, the answer to this question is no. Robert McNeese, an associate professor of physics at the University of Chicago, claims that the universe is isotropic. This means that it follows the so-called cosmological principle. That is, it has the same properties and obeys the same laws of physics in all directions. If so, then the universe is very similar to the surface of a balloon. Imagine that you are an ant crawling on a balloon. You wouldn't notice anything special if you just kept crawling and crawling forward. Eventually, you will probably go back to where you started from. However, you won't understand this if you don't leave any clues, and such a journey can go on forever. But if someone, put more air into the balloon while you continue to crawl on it, you would feel that some parts of the balloon have moved away from each other, right? But it doesn't matter, because you will never find the edge of your balloon anyway. Like ants, we are unlikely to get to the end of the universe. But one day we will probably be able to answer one question. Is it really infinite? Or does it still have some real boundary? So what do you think about all of this? Do you agree that the more we investigate, the less we know? Our universe is just filled with riddles, enigmas, and mysteries, just like I told you. And again, in order to fully understand it, we must overcome the invisible boundaries that bind our minds. Well, but since we have 100 million years left before the end of the universe as we know it, I'll bring you some more videos about the mysteries of the universe that our planet exists in. If that's really the case, because we do not know. The more we get into it, the less we know. And mysteries that I have discovered and investigated that pertain to its inhabitants, human, humanoid, or others. And we'll get into it, I promise. I wanted to talk to you today about riddles of the universe and its mysteries, and I think it's only the beginning. So we'll one day speak more about it. I thank you for your support, and if you can support me, you'll find the links in the description to this video. Please subscribe to my channel and please tell others about it.